The Alabama Industrial Assessment Center, you see in the graphic that I've taken from the IAC website, this shows the little blue dots are showing approximately where we have conducted assessments. I think on a lot of those blue dots, they're multiple stacks because they're pretty close together. But the large green circle you see is our nominal region of coverage, but we try to cover as much of the state of Alabama as we can. As you can see, we've been down in the Mobile area quite a bit, and up into the Florence area, and even down into Dothan. So we've covered all corners of the state pretty well. We've been operating now for about 13 years. Over 235 clients, it says here, have been served. We've recommended over $42 million in savings, but the plants don't always do what we say. I'm not sure why that is, but they don't. And so only about $7.7 million in implemented projects. Let's see if I can get this to go. There we go. So our mission is twofold, really. The first thing is to lend some direct assistance to manufacturers, and we say in the small to medium size, so that's scaled by the amount of energy that's used at the plant. So if there's more than $100,000 a year in energy costs, but less than about $2.5 million a year in energy costs, so it's a pretty broad swath. But the really large plants, or the ones that are pretty small, the mom and pop type operations, we're not supposed to work with. It says there the things we're supposed to help the plants with: energy efficiency, productivity, and waste management. I kind of put energy efficiency in bold red because we're funded by the Department of Energy and not the Department of Productivity or the Department of Waste Management. So our primary focus is on the energy efficiency aspects of their operations. The second thing that our centers do is we train the next generation of engineers in practice. They get in the field, so to speak, or on hands-on experience, going into plants, seeing a lot of different energy using equipment, understanding how that equipment uses energy, and more importantly, what's the best way to operate that equipment so that it uses the least amount of energy. So this is really, as I described earlier today, scattering seeds that the Department of Energy is doing, that they're sending out these students that have this expertise, and wherever those seeds land, they hope that they'll grow and they'll flower and bring their energy saving practices to bear. There's more. What's next? Okay, so what do we do on the energy assessment? It's really a one-day on-site visit. That's the second bullet that you see there. But prior to going, of course, we gather some information from the facility. We send them a questionnaire. They send us a 12-month history of their utility bills. And once we assign a team, we do some preparation. We like to look over the Google satellite maps and sort of see the layout of the plant and kind of imagine what's going on there beyond the information that we've been provided by the plant. So we go there for one day. We're on site for probably 6 to 7 hours. That green circle I showed our region of coverage earlier, we'll travel about 3 hours sometimes in the car to get to where we're going, and then we're there for 6 hours and then maybe 3 hours back. So those are the longest days. And when we have a client that's right there in Tuscaloosa or right there in Birmingham, that makes for a much shorter day. But still, we're on site about 6 hours. We go through and look at all areas of energy usage, and as I said, identify areas that they could be more conservative in their practices. So the last bullet is just saying that once we come back after the one-day visit, we do give them a closeout discussion and highlight the things that we've identified that are potential areas for energy savings. But we go back, work with the students in a 60-day timeline to develop a comprehensive report that details each of the energy savings proposals and the potential cost of implementing that proposal, and therefore a simple payback period attached for each one of those recommendations. So I think what I've got here are a few suggestions or areas that I'm having trouble with this all of a sudden. Yeah, let's go to typical recommendations. I'm going to skip this slide.
Next slide.
Yeah, there we go. So it's already been mentioned, LEDs are the way to go, and so in going from metal halide lighting, which is almost antiquated now but still is out there, you can get about a 50% reduction if you replace that with equivalent fluorescent lighting. If you replace fluorescent lighting with LED lighting, it's about a 50% reduction. And so, of course, if you are changing from metal halides directly to LEDs, there's supposed to be an arrow going down there, you're going to get about a 75% reduction, a huge reduction in energy usage. So I'm imagining that Polaris, that you have fluorescent tubes and not metal halide in your plant. Yeah, I'm struggling with this. Where's it supposed to hit? There you go. In the area of lighting also, I think was mentioned that if there is an opportunity to use some sort of controls to control the lights, that you can realize some savings. You can't just say, turn out the lights at the end of the shift and expect that to happen. So if you have motion sensors in areas that are going to be intermittently occupied, you can automatically get those lights out. Another thing is if you have some translucent or skylight panels that emit natural lighting and you have adequate natural lighting, make sure that you turn off or extinguish your artificial lighting. So that's something that we see quite a bit. In compressed air, use the most efficient type of controls. This is kind of complicated, and I talked about it at length earlier, so I don't know if I want to go into much depth on this. But essentially, you can either have a there's probably a red light on this. The top line there is the modulating controls. The dash line that's below that is a loading and an unloading control, and the very bottom line would be a variable frequency drive type control. And so the line that has the steepest slope is the most efficient in terms of the relationship between the power that's required to produce a certain amount of air. So as you're choosing control systems, yeah, this is maybe more than we wanted to talk about, but it's, if I can step through these arrows. One more. Yeah. So for 60% of required airflow, if that's where your compressor needs to operate, the modulating control is going to require about 85% power. The load-unload about 68%, and then the VFD would get you 60%. So you want to go with the most efficient controls. Second thing you can do in compressed air, I was pleased that two of the speakers previously talked about this. If you reduce the pressure in your system to the lowest level that you need to do the job that you're trying to do, I think we had claims of 10 and 20% reduction, 20 psi reduction, and that brings significant savings along with it. So reduce the pressure. A lot of people, it's a package system. It's designed to operate at 120 psi, plug it in and run it at 120 psi. But if you only need 90 psi to do your job, you need to turn it down and you can save a lot of money.
A lot of money.
Air leaks is another area. I think that's fairly obvious. If you're leaking out air, it's wasting money. But this graphic is showing some dollar values associated with that. But fix the air leaks that you have in your system and life will be good. Boilers recover waste heat from stack gases. That's a great way to save energy. If you've got a natural gas boiler, if you can preheat your feed water, or in some cases preheat the combustion air for the process, either one of those ways that you can recover that waste heat, you can save energy. And I don't know what else I've got in here, so yeah, let's call that the end and quit there. And thank you, and we can answer questions later.
So that's a real perfect segue to seeing how important the IAC is. And now you get to hear from actually a student who's a part of an IAC. He's not from Alabama, but he's actually from NC State in Raleigh, North Carolina, which is my alma mater. So I'm really excited to have him here. I'm also excited that he wants to move to Huntsville in the summer. And I think he would be a great asset to our community, as you'll hear with the experience that he's had in this energy world. For the past 2 years, he's worked in the IAC there and has been a part of potential energy savings of 134,000 million BTU of natural gas, and 26 million kilowatt hours of electricity. So it's impressive stuff. He's led over 20 audits, and he's also helped train several of the students, which I think is a really cool model. I don't know if it's like that with you, Keith, as well, but you know, the senior students probably, yeah, I wish that was around when I was, anyway. I'm really jealous, but I know you guys, so that's good. Alex, if you'd like to come up and share your experiences.
Thank you, Ruchi. As she mentioned, I'm here today to talk to you about a couple projects that I've had the luxury of working on at the NC State Industrial Assessment Center. So the first project I'd like to talk about is a de-aeration pond, or an activated sludge aerating pond. So this comes from a wood siding facility in Roaring River, North Carolina, and on the left graphic you'll see their aeration lagoon was kind of staggered. They had some random 75 horsepower and 50 horsepower motor driven fans just kind of staggered about through the aeration lagoon. So I looked at the setup and came up with a new idea and I created the diagram that you see on the right, and they actually implemented this, and it cut out 2 of the 50 horsepower motors. I worked with the University of Memphis's BioTiger analytics program for activated sludge out of paper mills, and the numbers determined that they would not have changed any of their flow rates or anything. All of the biodiversity, all of the activated sludge, none of that would have changed. All they needed to do was just readjust where their fans were, and they collected savings from this. And the implementation cost was overestimated on our end, which was good because it cut down the payback period even further. Next slide, please. So this recommendation was a water generation recommendation from a broadwoven fabric facility in Cliffside, North Carolina. So they had an air washer system, and during the summer months when it's very humid in North Carolina, the air washer will actually generate fresh water. So this is non-potable, unfortunately, so we decided to use it as cooling tower makeup water. So you can see the psychrometric chart on the right. So the set point is the top point, and the air washer both cools and humidifies the air simultaneously. And then once the air becomes saturated, it starts to dehumidify the air because the water will start to condense out through the cooling process. So at the end of once the final set points, the return supply air set point has been reached at 45 degrees Fahrenheit and saturated, which is pretty common for textile mills. You end up with a net gain of water in your air washer. So we said you can send this to your cooling tower instead of buying makeup water from the city. So they saved $6,000 a year, and the implementation cost was relatively cheap because their air washer was already on the roof, so all they needed to do was install some PVC piping from the air washer down to the cooling tower. Next slide, please. This was one of my personally favorite recommendations that I got to write. We looked at a mirror facility in North Wilkesboro, North Carolina, and they had a 3-oven system, but some of the mirrors were different widths than others. So on their conveyor belt system, they would have some mirrors that were 12 feet wide and then some mirrors that were 8. So because of this, the 8-foot mirrors had a lot of crackage and breakage, which resulted in product loss. So they estimated that about 3% of their product was lost due to uneven heating and cooling. So we recommended that they install infrared sensors and independently controlled oven controls, I guess, and that would allow them to turn off the 4-foot section of the oven where there was no mirror. So it would help the air, so the mirror would heat evenly instead of heating the air and then the mirror on top of that. So they saved about 0.75% of their product yield, and one of the metrics we used was their annual production rate, which it resulted in a cost savings of over $100,000 a year in pure reduction of loss. Next slide, please. So this was an automotive fabric facility in Hickory, North Carolina. They made the seating fabric for, I think Toyota, honestly, I'm not sure. But they had their knitting room, their knitting machines had, I think, 1,200 stitches per minute was what their machines were running at. And they generate a lot of heat, which is an issue for a lot of textile mills. So their HVAC system was running very intensely during the summer months. So we recommended that they install air side economizers in order to utilize outside air during the shoulder months, which you can see by this graph. The curve kind of peaks out at the shoulder months and then dips down a little bit during the winter months, but they're able to utilize outside air instead of cooling so the idea is that instead of cooling the return air, you dump that back to the atmosphere, bring in outside air, and condition that because it more closely matches your set points. They ended up saving $14,000 a year, and it was a relatively low implementation cost because they had an air handling unit already. All they needed to do was install an enthalpy sensor and an outside air vent. They relied entirely on infiltration, which was an issue because other parts of the plant were not air conditioned. Next slide, please. We recently went to a fiberglass veil manufacturer in Dallas, North Carolina, and they had a boiler system that was 37% loaded, and 90% of the steam generated by the boiler was injected directly into a hot water mixture to make hot water. So instead of making hot water via steam, we recommended that they use a heat recovery chiller where on one side you have chilled water being produced, but then on the condenser side, instead of dumping that heat to the atmosphere, you dump it to some hot water that you can then use and process. The facility is planning on expanding soon, and they are going to need about a 110-ton chiller, which coincidentally would fit their exact needs for hot water as well. So by implementing this, they could save $35,000 a year, and it does result in an electric cost increase. However, it does mitigate their natural gas extensively. Thank you.
See, the future is bright. I think there's a lot of great students coming out of these centers. Maybe even a Polaris or a Huntsville Hospital or a Toyota could benefit from some of those students and their knowledge that they've built. I have a few built-in questions, but I want to throw it to the audience. Raise your hands. If there's any questions, or would you like me to get it going first? Okay, I have one for Janine. One was about since you've been in this for a while, how do you decide on implementing a project that's going to have a fast ROI versus something that's a bigger savings but will take longer to make up on that?
Okay, so at our plant, we kind of do a mixture of both.
Yeah.
What we really, probably the biggest asset that we have at our plant is 1,400 team members. So a lot of the team members aren't energy experts, but they know their processes and they know things that'll make their job easier. So we have a team called the Kaizen Blitz, or our environmental team. So they come up with projects that are energy related or some type of environmental project. So those are the quick wins that we try to implement very quickly for them. And that gets our management more engaged, and they want more projects implemented that the team members suggest, because that not only improves our productivity, it's the team member morale. They want to be a part of the company. So I like those projects because it shows ownership to the team members. And a lot of those team members use those Kaizens, that's what we call it, that we help them implement when they get ready to get promoted to a team leader and a group leader. So when you look at those small projects that we can help a team member with, it has so many ancillary benefits. So I think those are the best ones. But then we have a group like that Clark's part of, Clark, Eddie, and Greg. That's our facilities team. Now they look at the more longer term strategic projects that are in line with our 2050 vision. So we have two different paths. Environmental really runs the team member driven program, and then the facilities group runs the long term, more strategic. And it's easier to get those long-term projects implemented or get monies approved for them, because we can talk about all the small projects that we implemented for the team members' sake. So I think if you have both programs, it's best.
Thank you. Thank you. I I think that's probably true at a lot of businesses, right? You have to
Yes.
balance, I know Dale's always telling me, you gotta balance the short-term goals with your long-term goals, and then, be willing to invest kind of both ways, right? Dwayne, I had a question about, I actually sat in a breakout session yesterday about the 50,001 certification, and in DOE, what they're saying is to just be ready, and you don't have to pay necessarily to get all the way to the certification. Was this a mandate from headquarters Polaris? How did you guys decide that you wanted to do that? And would you recommend it?
Yeah, so no, it definitely wasn't a mandate at this point. Will it come? It might. This was really more really setting up the architecture with the cohort we were working with TVA in order to, why reinvent what a strategic energy management plan should look like when if you design one that looks like what ISO wants to see, you're that much further ahead. So really, I'll say it was being smartly lazy rather than trying to come up with something totally new. We said, okay, this works. This is an auditable program, and the fact that the assessment tool was 100% free and you can just go through and it kind of just asks you a series of questions under each of the categories. I think there's 26 categories.
27 steps.
It pretty much walks you through exactly what you need. And it's nice to do it early to realize where the gaps are, and that really just forms your action plan, right? So you might start, even if you don't think you have a great energy plan today, you might do that assessment and find out, oh, in this part, I'm at 75 or 80%, and I'm just missing these couple of pieces. And then you might find in other sections you haven't really even started yet. So like I said, that kind of worked as a good working tool to kind of direct the team on what to work on from a system standpoint.
Yeah, and they were showing free tools of engaging people at your plant too, so everybody can get updates about their project. So I thought that was pretty neat from DOE to offer that. Rudy, I had a question with Huntsville Hospital. Okay, so you've got the largest utility budget I've seen. I mean, utility costs that I've seen today. There might be other people in the room, but definitely one of the largest, and one of the largest in our town. You have to make so many budget decisions. How do you make decisions? Is it always an ROI issue? Which one you're going to get the payback faster? But with you, you've got resiliency to think about as well.
It's not always that.
Yeah.
We have a little experiment going at Hampton Cove right now. I have a need there for vaccines to be protected in a refrigerator when the grid goes down. So I can buy a generator and put there. It's about $12,000, but then I have to maintain a generator and I've got to get fuel to it and that sort of thing. So I'm trying to push us to find something that I don't have to do that with. So there's American Wind has a little trailer set up out there now, taking wind readings, and I don't know what they'll propose, but we can't quite get it done with just solar.
Right.
And so, we'll learn something from that and use that in other applications. But we always have something. We have 4 billboards in town, and everybody says, well, why do you have billboards? Well, we have billboards because we had the tornadoes, and we're spending $100,000 a year advertising on billboards and that sort of thing. And I'm the one who had to lock the front door, when the tornadoes came, and nobody had anywhere to get food. And so for the first 2.5 days, they were coming in buying food, and taking home to feed their families and that sort of thing, and that was fine. But it started getting to where our stores were running so low, we weren't going to be able to feed patients. And I had to lock the door. And that stuck with me to have to do that when I know they don't have anywhere to go and they need help. So we kind of had this idea that it would have benefited them and the community if there had been a way that was continuously running for people to know what's open, where it is. Walmart at 36 and 65 is open, or whatever message you want to put out. So I got our marketing department to respend their $100,000 in a different way so that the $100,000 a year they were spending funded building these digital billboards in 4 locations, with the idea that we would figure out how to keep them up when the grid was down, so that we could put up this information for the community. So now I've got billboards and marketing's happy and they're doing all their advertising and I still can't run those billboards when the grid's down.
Oh, that's true, right?
So, I've not completed my task, but to answer your question, we always have something like that all the time
Yeah.
that is mission-driven, not money-driven, and my boss is not going to support me to go out to a billboard and spend $40,000 to make this billboard run,
Right.
When the grid's down. But if I can be creative enough and figure out how to do something with it, then he'll support that, and we will have accomplished what we set out to do.
Yeah, and if maybe we can show savings and then that budget being used for these type of investments, that may be another way to convince people. Dr. Woodbury? I had I'm really excited about the IAC. Were you one of the first IACs up? No?
No.
When did it get started? And
Program's probably 40 years old or so, and we got started in this, as mentioned, we're in our 13th year, so we've been doing this about
Okay.
13 years.
13 years. Are there any certification offerings for the students after they've gone through the IAC? I know that at Nexus, we promote things like BPI certification so that you can do energy audits in homes, or they have LEED certifications, or is there anything like that that you promote or help?
Well, there's a program within the Industrial Assessment Center program for IAC student certification, and it's offered to students that have demonstrated significant experience in the program, and it is a nice little certificate, but it's more a resume bullet that just says that they have a minimum level of capability or experience in the program. So there's that. It's not a very formal certification at all, but they can earn that if they go on at least 6 assessment trips and they are involved in the 5 facets, main things that they do, team leadership, evaluating projects, and several other things.
Yeah, I
So
know
they're
that.
recognized for that.
Right. So, and do they get a PE after? Are they encouraged to get the PE?
Well, there's a longer row to hoe to get to PE, of
Yeah.
course, but I don't know that IAC experience would directly benefit them in that. I mean, I think they get an indirect benefit, but
Yeah.
I would encourage all engineers to get a PE, but most don't. So
Yeah, and we encourage people to get the CEM as well, and so that would be, of course, they need to have years of experience in the work field for that, but that'd be a great next step. I just thought about how to make the students marketable.
right, we do try to offer to our students within our own center some kind of training opportunities, and some of those lead to a certificate of sorts. For example, we mentioned the ISO 50001. I think we've talked about the DOE 50001, but Georgia Tech has a series of training programs for the ISO 50001 program, and last year we had a cadre of our students all sign up for that and complete that training. It's sort of a first level training towards becoming an ISO 50001 evaluator or auditor.
Yeah, that's great. Thank you. Alex, I was going to ask, so do you go, when you go in and do an assessment at these places, do you have a professional with you? Is it a group of students or? Yes.
So usually the team consists of the director of the center. In my case, it's Dr. Stephen Terry. In Alabama's case, it's Dr. Bradbury here. Woodbury, excuse me. I'm so sorry. Dr. Woodbury. And usually it's a team of 2 to 4 students. Sometimes we'll have people from other centers at NC State's campus come with us. We recently went to a satellite dish manufacturer, and we brought with us someone from the Clean Energy Tech Center at NC State.
Mm-hmm.
They do mostly CHP analysis and things like that. It was nice to meet someone from that center. It was a good connection to build. We used to bring with us our assistant director sometimes, but unfortunately money ran out from the state, and
So
he left to do.
My real question to you was, because I have a hard time always convincing the end user of the benefits that you're noticing or that you're seeing could happen. Do you run into that a lot as well? And maybe this is a question for Dr. Woodbury too, is, how far do you go to convince them, or are there a lot of no's before you get the yeses?
It depends on the facility, honestly. Some people very much want us there and are very willing to implement our ideas. The first facility I brought up, I think, the aeration lagoon, they implemented everything but one idea of ours that we recommended to them. And I think the reason they didn't recommend it to them, they didn't complete the project, was due to intense capital at the beginning of the project. Some facilities won't implement anything we recommend and only want us there for a checkbox for a DOE Boiler-Mact survey or something like that. It really just depends on the facility, honestly.
Yeah. Okay, are there any questions from the audience? Oh, Janine's have a question, yes. Do you want the mic?
There's not a requirement for the companies that you go audit to implement something? I mean, if you're getting money from the DOE, shouldn't they be required to implement something?
So there's no requirement on the facilities end to actually implement anything that we recommend. Sometimes some facilities are very thoroughly energy managed, and we really can't recommend much. There was a plastic pipette facility in Durham, North Carolina we went to, and all of the low-hanging fruit had been picked already, and we spent 6 hours pretty much scratching our head and shaking his hand saying, "You've done a good job. Here's our best bets." And whether or not he implemented those things, we will learn, I think, in June of this year.
Anybody? No questions? We're a little bit ahead of schedule. Yes, Janine, do you want the?
There's a question there.
Oh, sorry, I'm sorry, yes. Mm.
If your site has already accomplished either ISO 9000 quality standards or 14,000
Environment.
environmental, you're, as you point out, you're 70%
Of the way, yeah. Yeah.
get there pretty quick. So, and half of it is the cultural things that come along with that. So manufacturing facilities are usually pretty good about making a head step. You already understand metrics and those kinds of things.
Mhm.
Another comment on industrial assessment centers. I work for ESCO, worked formerly at one of the national labs, and have been out on audits where companies have had industrial assessment centers in and not implemented the recommendations. And that would pay me.
Yeah.
And the first thing I always tell them in my report is, do this other
Yeah.
It's not an uncommon thing.
Mhm.
For whatever reason,
Yeah,
are challenged to do the obvious.
yeah. Those are great comments. Thank you. Yeah. Janine wanted to, or,
I'll stand there.
yes.
You got
good,
one in the
good.
back there.
There's another question, Richard.
Yeah.
As a student, did you audit the university for that?
So there are some requirements for the industrial assessment center. So it has to be a manufacturing facility. I think it has to have a SIC code between 2,000 and 3,999. It has to have less than 500 employees on site. It has to have at least $100,000 in utility bills, but no more than $2.5 million in utility bills. And I think there's a couple other standards there that need to be met as well. But those are the most important ones.
So the university probably doesn't.
The school definitely is not a manufacturing facility. That being said, the North Carolina,
Some bright minds, but yes, they're not a manufacturing facility.
despite not being a manufacturing facility, the North Carolina university system has been upgrading all of its lights to LED lights except NC State University, which is really ironic because my advisor who runs the center is the third-party measurement and verification person for the rest of the universities in North Carolina. Why NC State isn't upgrading is beyond me, but they're not.
I was going to suggest you make a deal with the school that any improvements, energy savings ideas you could give them,
I think. Yes, the BioTiger program from University of Memphis was a tool that we got to use through this aeration lagoon. It had a lot of information about the biologicals in the water that were, I think it's aerobic digestion, I think is the process. So they mix the water, they churn it up and add a lot of oxygen so the bugs can eat up all of the waste from the paper mill process, because while it wasn't a paper mill, the process was very closely aligned with the paper mill. So they had this big aeration lagoon in order to help digest all of their things from all their waste from the digester system. They do not. After they run it through this 10 million gallon lagoon over the course of 3 days, it gets dumped into the river behind them because it's considered freshwater at that point and can be safely discharged to the river. Come again? It's behind their facility in Roaring River, North Carolina. I'm trying to think of the river that it's on. I'm not entirely sure. I don't know the geography of the area, but the facility was a larger facility. We were worried that we were going to run out of funding, and they were very interested in an IAC audit, so we broke the $2.5 million utility budget limit. I think they had a $9.7 million utility budget, so that was a big overstep. We had to ask for forgiveness on that one, I think.
So I just had a comment. I know Keisha's not in the room, but I'm glad that she has included manufacturing at the table, because I know when I met with Jay and Cedric and, of course, Rushi several years ago, I felt like that only little manufacturing plant in Huntsville, and I would sit in the room and they'd be talking about all this government stuff, and I'm like, it actually has nothing to do with me. So through meeting them and meeting other people, I've started to see manufacturing being discussed more at the table. And in Alabama, manufacturing is growing. Automotive is growing, and definitely manufacturing is growing. And, you know, I'm embarrassed that I haven't met either one of these gentlemen before now. You know, I've been doing energy management for 16 years in Alabama, in the Huntsville area. And I know you were at the Huntsville Hospital for many years, so. Yeah, no, you're not old. But, I mean, it just goes to show that, you know, we all work in these little silos and we get so busy that we don't get the opportunity to share. I know I wrote down a lot of things that I could take back to the plant in Alabama and Mississippi, and a lot of things that we've all done that if we had have done them together, could we have saved more money? You know, and looking at the government, you know, talking to like Sophos Harbor, what other type of renewables can we collaborate together on? And I'm kind of upset that I wasn't part of the cohort. So I wrote that down to go talk to TVA. They're like, hey, why didn't you invite me to be part of the cohort? I always like being part of things. But, you know, I say all this to say collaboration is good. Getting outside of our normal day-to-day and talking to other people is great. Student activity, I know I invited the Alabama A&M students because we're partnered with them on projects. So not only is it about our plant or our companies that we work for, it's also about the community, and it's also about getting young minds, because, you know, as we retire, we want energy management to continue. So we have to get the next generation involved in the things that we've started and people before us started. So I just stood to say, you know, just try to collaborate with other people, get into the communities and do things, and, you know, get contacts with people. So if we're working on a project, I can shoot an email to Polaris or Huntsville Hospital just to see, have you guys done this? What were your pitfalls? What are the things that I can avoid? You know, I could waste $10,000, or I could pick up the phone and call somebody. So definitely this is a great opportunity to network and get to know people that you can bounce ideas off of, and of course Yokotan or steal other people's ideas. So.
Yeah, great. I think it's almost like It's almost an action item, Janine. I like that you're ending this with an action item. I know my friend over there, he was talking about how we don't talk about challenges enough, and we always talk about all of our amazing solutions. But I loved how I felt like this panel talked about some of the problems, energy. I've been to Polaris, and I was so impressed, and he was like, oh, Ruchi, you're impressed, but look, we overdid this, this, this. Look at this tunnel. We put a light over a tunnel. Why do you need a light over a tunnel? And I'm like, I don't know. So, things get built quickly for a production reason, for a mission, like the way the federal government works.
Yeah, so it was interesting. I mean, the plant was laid out and the lighting system was laid out without really worrying about what was underneath it. So we've got a project now. We're taking out 300 something lights just because they're over top of stuff that's 6 feet away from them.
Yeah.
They're lighting the top of nothing, right? So, like I said, some of this stuff that you do, as much as you talk about all these big projects, there's so many that are just go do it, and just basically just finding the time to do it. It's amazing when you track them, how much that was actually add up to.
That reminds me of a funny story. We have a construction group, and they just build the buildings. I mean, they don't really care. We'll go in and say, don't put that in there, don't do this, don't do that. We're just going to rip it out in a year, and that's just stupid. You're wasting Toyota's money. But, they just have their agenda. So we got the president of Toyota North America came to our plant, and the PLE group and the PE group is still mad with me because I told them, I was like, this is what I've spent your money on to Kaizen things that are less than a year old. That's wasting money versus the things that I could have been doing that would have, made a big impact. So I was like, so after every construction project, there's 2 types of Kaizen. We Kaizen to meet the standard, or we truly Kaizen to improve our processes. And this wastes a lot of money. So, you have to, when you get the ear of people, tell it. Sometimes we can, now they come back and say, well, we're thinking about doing this. They still try to sneak things in on us, but at least now they come and ask most of the time, so.
Yeah, that's really good. You can hold on to that. I was going to say, too, I want to challenge the panel here to start thinking about data analytics. You've been talking about, and Janine just touched on it, and so did Dwayne, but making decisions without really looking at historical data or performance data is tough. And I'm just wondering if we all work together, there might be a way that we could start pooling everybody's data and really being smart about the decisions, because that's the problem, right? There's not enough money to spend on a bad decision. So whatever we can do to make a smarter decision, I think it's just really worth it. And there's some really interesting tools and methods to go about doing that now. And I'd like to lead a group in seeing that happen. So you'll be getting calls from me about that. And Bob and Nadine and I, we're all very much committed, and we're offering these data solutions to the government. Why can't we, offer these solutions to our local businesses who really need it and have the same resiliency and efficiency challenges that the government has? So, yes. Yeah, Bob.
When we start looking at data analytics and growth, we talked about this a little earlier in the sessions, but we got to understand that energy underlies virtually everything we
All the
do
processes, yeah.
inside today. So there's this broad spectrum of things that we ignore, but with the power of the data analytics tools we have today, we can bring in other resources. For example, if your community energy monitoring system is looking at this, like say the utility, for collaborating with the utility, the police will know which buildings in a natural disaster still have power and which ones don't. If you're on a campus, and there's some activity going on and something shuts down, or you have the same thing, even if it's a campus like a manufacturing campus, right away, your security forces will know where things are, where they're not. That's just integral to having these systems out there. It's not like we're adding another system.
No.
We're just analyzing the data
Yes.
that's already there. And then we can also look back to like human resources and other areas and say, how is this impacting our workforce? We did some changes over here, and wow, now there's more people out. Is there really a correlation to what we did here
Yeah.
and this absenteeism? Because we could track with
Yeah.
the financial people how much production we get done that day and what
Yeah.
was the exact dollar value losses to the company. Well, now you've got that power to go back again
Yeah, and I think these commercial customers can benefit from some of the work we've already done with the government, who they aren't just they aren't just facilities; they're also facilities producing something. So at an AMC facility, they're doing vehicle work and all of this stuff, and they're implementing this whole, how can we still be productive, meet a mission, but be efficient? And that's how you do it. And you have to look at so many factors. And I think for a while it was cumbersome to look at so much data in so many different formats, but there's solutions now to do that, which is, you guys need to take advantage of, yeah.
Yeah, we try to look at data and bring it to production real time. So production's data is very good. It's real time. But you know, energy is kind of in the hands of 3 or 4 people. So how do we get that in the hands of 1,400 people? Like they can tell you at 12:55 whether they're going to be working overtime or not. They just look up at a little monitor. Oh, we're going to be here 30 minutes. We're, behind on production. So that's some of the things that we're challenging ourselves, is to get that data real time. But I didn't think about the other part of how do you take it to like emergency management organization and stuff. If you have the infrastructure there, you can do that. I know we can tell if there's certain areas of our plant down, like Clark can log on and what's the temperature in this area, what's this, or Eddie or any of the team members there. Or if we have something down, we get alerted immediately when it's down, and we don't waste time tracking something. We know exactly where to go. But how do you put all that together and have, one very robust system that everybody can look at? That's a good point.
You have occupancy sensors for your lights. Well, if there's a fire in a building, that occupancy sensors will automatically tell the fire department where there is
Yeah.
people.
How do you
or
utilize
if there
that?
was people at that moment, you need to go check.
Mhm.
Another thing on data analytics that is kind of cool is, I didn't get a chance to present this part of my thing, ran out of time, but by looking at your power quality, and I brought up some papers about that, where if you have too many harmonics, it actually changes the dimension of the machine tool.
Yep.
So now you have rejected parts that you have to go back for rework or rethought.
More money.
And the cost of that is way higher than what we're doing with that power. So all of this can be looked at, like we're saying, real time. And there's where your advantage is in energy, is going back to your management and saying, hey, we're saving you millions of dollars, not tens of thousands.
Yes.
Yep. Cool. All right, I think we did it. Cedric? Real quick, if I didn't, let's give a round of applause, sorry. I really appreciate their time. And these are busy people, so they've left work to be with us today, and I really, really appreciate that. April 6th, Energy Greenway ribbon cutting. Please, please come, 10 a.m. September 20th, Green Tie Bash, 5:30, and that'll be at the Space and Rocket Center. You don't want to miss that. It's going to be an awesome event, both of them. And I think both of them are going to open up to even kids. So if you have well-behaved kids, we'd love to have them learn about well-behaved. Like Janine and I, we have well-behaved kids. Please bring them. And definitely for the Greenway, that's going to be a fun family event. Wear your company T-shirt and really show some solidarity about supporting Energy Greenway and outdoors and Space and Rocket Center and Nexus Energy Center. So thank you so much. I appreciate it.
I want to say thank you to this team, and a couple of things that I noticed. I had the privilege in my younger day, this gentleman and I, we've been blessed not to have gray hair on top, so you can't tell exactly how old we are. But you both of you guys were talking about problems that you faced, and when I was in designing nuclear plants, we actually modeled. And the thing about this model, it saved a fortune. And when I say a fortune, I don't know what it was, but we would have built an entire turbine generator for a nuclear power unit incorrect. And that meant we would have had to tear it down. And the two walls that we had messed up, they were like 4 foot thick and 300 feet long on both sides. But instead of getting it where it was supposed to be, they flipped it inside and the turbine generator never would have fitted in. But the model told the difference. The model told us when we messed up with lights and pipes and all that kind of stuff. So that's something to consider on the front end that could help energy production on the back end and save some money that you could spend on other things. That was just one of the things. So that was just some good stuff that you know, sometimes we forget, if you don't build it right, you can't operate it right. And so that's just something to put in there. And when we first asked for it, everybody said, well, we don't want to spend, you know, $2.2 million to model this, except it would have cost us $200 million to, you know, so that $2.2 million was a drop in the bucket, you know. So these are some of the kinds of things that you got to look at. So some of the stuff that's been used, it was Neanderthal, but it works. And if it all comes out right, then you don't have to take out 300 lights.
See, that's how we kind
Yeah.
of feel about data analytics. You know, it's a
Yeah.
small investment upfront
Yeah.
to make
Right.
smarter decisions.
And so the modeling on the front end is the same as data analytics on the back end. They both do this kind of thing. So that's just some of the stuff that needs to happen. But here's what I want to say. Y'all have been good. That's just all it is to it. Especially the 30 or so that hung in here with us. Because, you know, whenever you're the last speakers, you don't get much. So you guys are the cream of the crop. And we thank y'all for being here and helping. So I have 2 or 3 things I'd like to say. Number one, thank you. My first thank you goes to Keisha. I don't know where she is, but the reason that thank you goes to Keisha. Without Keisha, you know, she just helped to make all of this come together, and her whole team. Now, she has 3 particular people on her team that I want to call their name. The first person is Heba Pierce. That's Keisha's daughter. She doesn't even know anything about the energy, but she just shows up out here and works her poor self to death. And we're just thankful for that child, you know, and that's part of the reason we're here. And then Nadine. Right here. Put your hand up, girl. And she just does whatever needs to be done. She doesn't care. She just does it. And we thank her for that. And then lastly, Faith. Faith sat at that table. See, Tricia got ill during the midst of this and couldn't be here. So we just had people to step in and make this happen. And thank y'all very much for making that happen. So the whole team and then the rest of Energy Huntsville, well, y'all deserve an applaud too because it worked. And man, I was smoking nervous coming up on this, and then this thing worked out. So we're there. And then I want to thank all the speakers. We had the best of the best, including all you great guys. Had the best of the best. And now I want to thank the Rio group, the attendees. Without you, we wouldn't have had this. So thank you to all your attendees. You came from far and near. And somebody told me where I was supposed to say, but this morning when they started saying they were from Guam, forget the United States, they came all the way from Guam to be here. So, you know, we just had a great group. And then we need to say this. All the presentations will be on the EHI website. So, you know, a lot of things you didn't get, you didn't do this, it'll be on the EHI website. Also, there's going to be an opportunity for others who didn't come to sign up, and you got to pay a little money, but all of the main speakers and the main panel, it will be video recorded, and they can take that as a session, so you can pull that down. It's going to take us a little bit, and we'll say it, but it should be up in 2 or 3 weeks, and that will be happening. When you registered, you received a survey. White piece of paper. It came from some glorious guy by the name of Dr. Bob Strait. We love the fella. But if you would, if you haven't, there's a box on the table. Please fill that out. Throw it in there now. It may not mean anything to you, but it means everything to us. We need to know this. We want to make this better. Even though I think we had a great summit, but we want to be better than great next time when we do this. And by the way, about 12 months from today, we'll be having this again. We're already going to start planning in a couple of weeks, so we'll be having this again. So we need that information from you. And all I can say is thank you for being here. See you in 2020. And then we hear from the voice of Energy Huntsville, Mr. J. Newkirk, if he has anything to say.
Well, I'll second what Cedric said. Having you all hang in here this late is pretty impressive. You know, I'm a delegator, so I'm really excited about Cedric being our executive director. He's really good at what he does, you know, and I was doing this myself a great deal in the early going, but now I'm able to sit back and lead and motivate our team to move forward. We are becoming a center of excellence here in energy. The DOD people that came down from D.C. recognize the fact that we're doing something special in the energy sector for the nation. So next year, we're going to talk to those guys into coming down here for sure in strength and co-hosting it. So they'll bring people from all over the country to join us next year. So we're excited about this event. It was very well done. Keisha and her team did an extraordinary job. So thank you all for participating and being here. And certainly, we're trying to get better. We don't have all the answers. We love hearing from you. In fact, we've learned how to listen. I do more listening than I do talking these days. So tell us what we can improve. And we appreciate the accolades because we've gotten a lot of positive feedback from our event, but how can we improve? One of the things I know we've got to do, and I'd like to get some input from all of you all when we can, and that is promoting an event like this is an art. And I'm not sure we have the committee members or focused people in our organization to really know how to promote an event like this to really bring 1,000 people here. So we're going to work on that, but we want to thank you again for being part of it and being with us and continue to support Energy Huntsville. Thank you again so much.
So, we're done. Thank you. If you want to network or hang around and talk, do it. But thank you very much. Look forward to seeing you in 2020.